We've spent decades trying to teach machines how to think, but we completely ignored why they will never feel. While your brain fires in a chaotic, parallel symphony of intuition, the world's most powerful AI is still trapped behind a mathematical bottleneck. Is empathy a calculation, or is silicon simply a biological dead end? Your brain experiences reality as a dense wash of chemicals and physical context. A machine, however, is forced to chop that exact same reality into discrete floating point numbers to process it. An artificial intelligence can parse a human text message, identify a statistical pattern of sadness, and output a comforting sentence. It successfully predicts the correct string of words based on probability. But predicting the right words to say is not the same as feeling the grief it describes. To understand why machines are locked out of human intuition, we have to look at the physical blueprint of modern computing, the von Neumann architecture. In this design, the place where a computer stores its data is physically isolated from the place where it does its thinking. This physical isolation means a machine's memories, its massive data sets and learned parameters, live right here, etched into these rigid memory chips, isolated from the central processor. Because the processor and the memory are separated, data must travel across a connecting bus. This creates the von Neumann bottleneck. Massive amounts of information are forced to squeeze through this narrow channel, pumped back and forth, one single word at a time. Instead of grasping a complex concept all at once, the machine is forced to evaluate reality in a strictly linear sequence. Human emotion is simultaneous and noisy. You feel fear, cold, and surprise all in the exact same instant. A serial computer cannot evaluate multiple overlapping truths simultaneously. It must resolve one calculation before it is allowed to move to the next. Your brain operates on a completely different physical model. In biology, there is no separation between the hard drive and the processor. Every single neuron acts as both memory storage and processing unit at the exact same time. The contrast in physical effort is extreme. Look at the scale of this enterprise server infrastructure required to train modern AI models. Achieving machine intelligence requires massive physical real estate and generates extreme heat. To perform basic functions, these server clusters are constantly shuttling gigabytes of data back and forth from their memory banks to their GPUs. It is an energy-intensive process just to keep the calculations moving. Meanwhile, your biology takes in millions of sensory inputs from your eyes, ears, and skin and processes them locally. The data never has to travel to a central hub to be understood. Human intuition arises from this intertwined, simultaneous architecture. While biological thought is distributed and efficient, serial servers remain locked in a cycle of moving data back and forth, a process that requires massive energy just to simulate a fraction of this biological complexity. The tech industry often argues that new neuromorphic chips are solving this problem by physically copying the brain's structure directly onto silicon. But the underlying reality is mathematical. Machine learning is built on massive matrix multiplication, where the system adjusts numerical weights across a grid to find statistical correlations. AI hardware executes this by relying on electrical principles like Ohm's law. A voltage is applied, and the current automatically seeks the physical path of highest conductance to mimic pattern recognition. There is a massive gap between an electrical current following a path of least resistance and a person reacting to their environment with trauma or joy. Silicon lacks the evolutionary pressures of mortality and physical pain. Without the need for biological survival, a machine can calculate a reaction, but it can never share the stakes of the situation. Increasing data density and optimizing matrix math within a crossbar array makes a system highly efficient at sorting information. It does not mean the system will spontaneously cross the threshold into lived consciousness. The tech industry measures progress in flops, floating point operations per second. The assumption is that if we simply calculate equations fast enough, generalized intelligence will emerge from the sheer volume of math. But calculating equations at a higher speed only perfects a machine's capacity for cold logic. Moving numbers faster does not build a bridge to intuition, it just makes the rigid sequence shorter.
Empathy is a structural requirement of being alive.
It is a biological necessity for protecting the group and ensuring survival, not a scheduling algorithm or a software update you can install on a server. Analyzing the variables of a situation is a mathematical exercise. Suffering the consequences of that situation is an act of living. As artificial intelligence continues to master the realm of perfect sequential logic, our responsibility shifts. Humanity must fiercely protect the messy, inefficient biological spark that allows us to connect with one another. A screen can display the patterns of grief or joy, perfectly matched to an algorithm's prediction. But that mimicry is empty when placed against the irreducible, uncomputable reality of human life. Discover more about the technologies and biological systems that shape our reality. Click the subscribe button, activate the bell, and join us for the next investigation into the complex mechanics of our world, only on TEMBODocs.